Hello, my name is Janos and I will talk about benchmark SLICT to HD mapping. You can see the link to this algorithm. It is enough that you click link and then you are in the SLICT converter. Hint, please change branching to bunker dataset. Because we did step 1 already in previous algorithm, so let's jump into step 2. So let's open terminal and follow instructions. Just copy paste. So we create folder. We go there. We clone repository. So once you clone it, then you go there, then you check out to our branch of this experiment, and then you build the Docker. So the idea is that all of your experiment is stored in this HDMapping folder. You can see everything is well organized and the data should appear in this folder. So let's continue. I will explain you more when the data is calculated, so we will have more time. So now we go to enter, we start step 3. So we run experiment. So we change some params of the files, accesses. We go there and we run our experiment. This so we start running experiment, and now I can justify, or I can give you some comments about it. So first of all, this software is in ROS 1, it is already obsolete, so let's observe if authors will provide this in ROS 2. ROS is robot operating system, so yeah. Okay, so this is the result. It's not so promising, but we will wait. The goal is to show you end-to-end solution, how to start, perform experiment, and then how to export data that you can quantitatively and qualitatively compare with ground truth. Why ground truth? Because we have this bunker data set, and our colleagues from Royal Military Academy provided this, and Ghent University provided this data set, and this data set is collected in bunker with this sensory toy equipped with 3D LiDAR, active, passive, time-of-flight cameras, and also IMUs. Most significant is that you have ground truth thanks to geodetic device, mobile map, terrestrial laser scanner. Okay, so you can see that the trajectory is completely wrong, but don't worry, we will continue the experiment. So the goal is to show you end-to-end solution. I will back to our project, HDMapping, and what you can see in this project is that our goal is to find, develop, discover best end-to-end mobile mapping framework. We start from our own solution. We provide our own LiDAR odometry, postgraph SLAM, and georeferencing. This set of tools is semi-automatic. For this reason, we start thinking about using AI for loop closures and so on. We are doing this now. I hope it is somewhere. I hope it is evident there. Yeah. Oh, we start working on automatic loop closure, and we hope applying AI for edge detection, some finding errors between certain nodes in postgraph SLAM, and finally we can apply postgraph SLAM. The idea is to collect all LiDARs, affordable LiDARs. You can see we have most of popular LiDAR systems in the market, and obviously speaking, we perform this experiment, we draw trajectories and we apply to certain quantitative and qualitative benchmark. We have already 20 of these algorithms and we have rapidly growing to-do list. We can see a great interest in such mobile mapping systems in literature, so it can be a fascinating journey to find the best one. By best one I mean that the algorithm is supposed to give you most accurate, most precise trajectory and map in the same time. I lost my okay. You can see that the algorithm is lost, so it's quite difficult to see anything. But don't worry, it is an example, like for example in our plot. What is interesting is that once you draw all trajectories from all algorithms, not every algorithm is sufficient for a certain scenario. So we are also focusing on the certain different scenarios. In that sense, we claim that it's very difficult to justify which algorithm is best. The best in what? The best in accuracy, precision, or maybe robustness, and so on. That is why we are doing this benchmark. I hope you will find something interesting for you. Oh, it is working not so good. Let's wait a little till it finish calculations. I will not touch screen, so let's wait a moment. There's nothing happening here, so I will back to the project. So basically you can find, for every algorithm that we benchmark, we can find reference and movie. What we are doing now, it is SLICT, this one. So if you go to this link, then you have instruction, and each algorithm, or each, sorry, not algorithm, but each scenario, its data set has its own branch named with the unique name of the dataset. So we switch to this, and then you can see that we have these very easy steps to perform what we're doing just now. We are waiting still for finalizing. It's quite challenging dataset, so the results is not always proper. Oh, it is finished. So we expect some results in the folder named SLICT. It should appear soon. We have our previous results, but we are expecting having results in new folder. Let's wait a little. It is exporting now the data. Even the data and trajectory is not promising. I am showing you this end-to-end solution. So from the running experiment on certain data set, you can export it to trajectory and point cloud, that it can be visualized in Cloud Compare. Okay, so our new folder appeared. It is still exporting data. Okay, and we have our result. The most significant is session JSON file that we will open. We will use our tool multi-view TLS registration step 2 that you can find on our project. You can open this session. So let's find this session, and you can see the session file, you can see the trajectory, and you can export it to Cloud Compare. So file, save all mark scans as a global scan. So we will name it PC global LAZ, and we will save all trajectories in XYZ quaternion format. So trajectory global.csv. So let's back to our folder, and we should see PC global and trajectory global. We have our file, so let's open Cloud Compare. And in Cloud Compare, you can see that we can simply drag and drop our exported data. And trajectory. And we have XYZ coordinates. It looks proper, so let's continue. So if you are familiar with Cloud Compare, you can use this as a result. Maybe this one can be used for some art, because it looks like scientific art. I don't know. It's definitely not engineering map. It is not good. But don't worry. I believe that this algorithm can work in different scenarios, as authors reported in the literature. So this is what you have from our benchmark. And let's back to the SLICT algorithm, so you can find more. Here. So let's back to this SLICT, and if you go to the this linked, then you have SLICT, and you have this fantastic algorithm well working on different datasets. Unfortunately, there is no movie, but it looks very interesting looking at where it was published. So I believe that it is very good algorithm, because it is accepted by RAL, so should work very well. But anyway, thank you very much. See you soon.